All right. Before we get started, one more time, just to make sure everybody knows. Don't forget your math 1241 homework number 1, also known as test review number 1, is due on Friday, February 2nd, by 3:30 at our review session. If you need to turn it in earlier than that, that's fine. Make sure you get it to Katrina in the back there. Now remember, the material is only going to cover through section 2.2. We're moving on today, even though I finished up section 2.2 last time, which also means if we turned it in on Friday, I'm going to actually record that particular day because I'm going to go over this entire homework set with you guys. And therefore, your test 1 will actually be on Tuesday, February the 6th. Okay, and what exactly are you expected to do? So, with this homework set, this is what I want you guys to do. Print yourself out a hard copy of this thing, and I want you to actually take it like you're taking the test. You know, I want you to look at it as truly as a true test review. It's located right here, homework number 1, test review. Click on this thing. And there's your hard copy of it right there. And then let's see here. You can go in, and once you actually have the solutions written down and stuff, you can go in, and you have to go in and I just do the preview thing because I'm the professor. But you go in there and you actually answer all the questions. Remember, it's a randomized system, so the answers that I actually made up on the hard copy, there's going to be there. It's just going to be jumbled up in the other answers. So just because it's A on question number 1 doesn't mean it's going to be A on the computer here. So fill this thing out. I even made multiple choice answers out of the free response. But most important, by Friday, what do you guys actually have to turn in? You're going to turn in the free response part. Now, don't have to turn in the multiple choice part, but the free response, which starts at part number 2, the one that you're required to actually show your work, which means I want you to be detailed, I want you to be neat, I want you to be organized, I want you to do the work on the paper, put the answer in the blank. We want to connect the work to the answer that you actually did on the little the set there. And this is the part, so it's the second part of the homework packet that you'll be turning in. And like I said, on Friday, I plan on going this entire thing. And my goal is to do this entire thing and show you that it can be done in about 75 minutes, which is exactly what I have allotted for the review time and stuff like that, which is your class time. So look at this as the good length of a test, is what I'm trying to say. Okay? So study hard on that. And so, all right. Yes, question.
I see we have 2 attempts on this. When we submit it the first time, does it give us feedback on whether we got it right or not?
No, because it's not going to give you any kind of feedback on that. No. Yeah.
So I read that we weren't supposed to use graphing calculators. Is that right? Or did I read that wrong?
No. Second test will be the no graphing calculator. This test, you can have calculators.
Okay.
Yeah. So good point. On this test, we are going to have a test that has no calculators on it, but it's not the first test. It's actually the second test that has the no calculators. So this test, you'll be allowed to use your calculator and all that good stuff on it. And you'll see why when I go over today's material, why we're going to have a no calculator part, which will be your test number 2, which is typically on the final exam. There's that no calculator section on the final exam. You're going to see that material actually come out of mostly test number 2 material. So that's why I'm not going to allow a calculator on test number 2. Okay. All right. So just want to get you guys set up on that. Last time, we pretty much finished up all of section 2.2, but there were 2 problems that I did not get to, but they're actually not section 2.2 questions. They are just general questions to get you guys excited about your first test. So they're practice problems to see if you guys know some stuff. And so it was problem number 9 and 10. So let me blow those guys up right here. And here we go. See if you guys can do this one. Evaluate the limit as x approaches 1 of x cubed minus 1 over x squared minus 1. What's the first rule of limits? This is the work I want to see. What's the first rule of limits? Plug it in. When I plug this thing in, I'm going to end up getting 1 cubed minus 1 over 1 squared minus 1, which is 0 divided by 0. Which means I got to do what? Do algebra. All right, so I'm going to clean this guy up, and the algebra I'm going to do, because they're polynomials, is I'm going to factor it. So I'm going to take the limit as x approaches 1 of x cubed minus 1 over x squared minus 1. Well, x squared minus 1 factors into x plus 1 times x minus 1. My question for you, if you remember from high school, how does x cubed minus 1 factor?
X
Go.
squared minus 1 and then multiplied by x plus 1. And then you would factor it out again. So it'd be like,
No, that doesn't work like that.
yeah.
No.
Is it?
Oh. A cubed minus b cubed. Now, how does that factor?
X plus 1 multiplied by x minus 1 multiplied by x plus 1.
I don't have to think about that. X plus 1 times Okay, write that one down for me. Hold on. Okay, x cubed minus 1. You're saying it factors how?
X plus 1 multiplied by x minus 1 multiplied by x plus
Like that? No. Sorry. No, you lose. Let me show you. It's a special formula called the difference of cubes. This one is actually x plus 1 squared times x minus 1. That's not going to be the same thing. Let me show you how it actually does factor. The difference of cube formula is what we were trying to quiz you on, whether you remembered it from high school or not. And that is a cubed minus b cubed factors into a minus b times a squared plus a times b plus b squared. Oh, sorry, I'm off the page here. This is how the famous difference of cubes factor. And by the way, just in case you need to know it, the sum of cubes, a cubed plus b cubed factors into a plus b times a squared minus ab plus b squared. And these quadratic parts over here do not factor. Okay? So this is the famous difference of cube formulas and the sum of cube formulas. So with x cubed minus 1, what you need to know is that x cubed minus 1 is the same thing as 1 cubed. So using this formula here, a is equal to x and b is equal to 1, plugging in an x cubed minus 1 cubed, that would be x minus 1 times x squared plus 1 times x plus 1 squared. So if I clean that up, that would give me x minus 1 times x squared plus 1 times x is just x plus 1 squared, which is 1. So x cubed minus 1 actually factors in as x minus 1 times x squared plus x plus 1. It's called the difference of cube formula that you supposed to have been beaten to death in high school, that when you get to college that nobody remembers. Okay, you had it in algebra 1, algebra 2, somewhere around math 2, math 3 sometime. I promise you, you did cover this. Okay, all right, but there it is. So again, it's there to scare you. All right, so what cancels? X minus 1's cancel. This leaves me with the limit as x approaches 1 of x squared plus x plus 1 over x plus 1. And once you cancel, what am I going to do? Plug it in. This would be 1 squared plus 1 plus 1 divided by 1 plus 1. And notice, once I plug in the number, I don't write limit anymore, which is equal to what? 1 squared is 1 plus 1 plus 1 is 3 over 1 plus 1 is 2. The answer is actually 3/2. Does that make sense? Questions? Yeah.
So the 1 minus 1, they cancel. That says that there's a hole right there. Correct?
That's correct.
Do we have to specify that for any reason?
if I give you an algebraic problem and state, here is a function, x cubed minus 1 over x squared plus 1, what does the graph look like? Tell me where the vertical asymptote is at. The vertical asymptote would be x equals -1. That's the factor that didn't cancel. The factor that did cancel would have been where the hole is in the graph, which would be at x equals 1. But this was not one of those kind of problems. This was a straight limit problem. Okay. But when you get 0 over 0 and you take the limit and you get a number, well, basically what's happening here is there's going to be a hole at the point 1 comma 3/2. Right, let's take a look at the next guy. Next guy, okay, isn't as bad. I'm trying to make you guys memorize high school formulas and stuff. And it's this one. Take the limit as x approaches 0 of the square root of x squared plus 36 minus 6 over x squared. First rule of limits, what am I going to do? Plug it in. This will give you the square root of 0 squared plus 36 minus 6 over 0 squared. Well, 0 squared is 0, plus 36 is 36 squared, 36 is 6 minus 6. Hey, I was surprised. 0 over 0 squared, which is 0, which means I'm going to do algebra. The question is, what kind of algebra am I going to do to this problem? The square root of x squared plus 36 minus 6 over x squared. The conjugate. This is you're taking the limit as x approaches number of something with a radical plus or minus something or other. That the trick is going to be conjugates on something like that. So I'm going to multiply by the conjugate of the square root of x squared plus 36 minus x, which gives me x squared of x squared plus 36 plus 6. And what I did in the numerator, denominator, square root of x squared plus 36 plus 6. And remember, you always full out conjugate pairs. So this is equal to the limit as x approaches 0 of, what is the square root of x squared plus 36 times the square root of x squared plus 36? X squared plus 36. What happens to the outer inner when you full it out? They cancel. So you don't actually have to write that out. You can if you want to. I'll write it up if you really want me to, but you don't have to. And I'm trying to do it like I would expect you guys to. But on fulling out conjugate pairs, you got to multiply the first and you got to multiply the last. What is -6 times a +6? Minus 36. Over non-conjugate pairs, leave factor. X squared times the square root of x squared plus 36 plus 6. Here, clearly the 36 cancels. So this is the limit as x approaches 0 of x squared over x squared times the square root of x squared plus 36 plus 6. The x squareds end up canceling, which is equal to the limit as x approaches 0 of 1 over the square root of x squared plus 36 plus 6. And once you cancel out the part that made the 0 over 0, in this case it was the x squared divided by the x squared, I plug in my number, and when I plug it in, I don't write limit anymore. This will be 1 over the square root of 0 squared plus 36 plus 6. The 0 squared 0 plus 36 is 36 squared, 36 is 6. So this is 1 over 6 plus 6, which is 112. Does that make sense? But again, don't just look at the work. Work's important. You got to know how to do the math. But I want you also to pay attention for the free response part on how I wrote this thing up. You know, limit, algebra, cleaning it up, limit, algebra, cleaning up, limit, I have a function cleaned up. Then once I plugged in the number, I don't write limit, and then I circle my answer. Basically crunch the numbers. Does that make sense? There's a standard pattern we're looking for on this stuff, and that pattern is what we really want to make sure you guys understand. The mathematical process of how to write up a solution. Not just about getting the right answer, but how you actually show how you got the right answer. Does that make sense? All right, turn page. All right. Now, get you guys started on this stuff. Here is the big deal. If I ask you on the test, which I'm going to, find the derivative of f of x equals, I don't know, 2x squared plus 3x minus 5 using the, this is going to be a key word here, the definition of derivative. Definition of derivative. That's all we did in chapter 2.1 and 2.2. Really focused on 2.2. Please tell me, what is the definition of derivative? Limit as h approaches 0 of f of x plus h minus f of x all over h. Right? So, I gave you a function. There's f of x. What would f of x plus h be equal to? Well, remember the rules of high school algebra 1, algebra 2 here. Whatever's inside that parentheses is what I'm going to stick in for the x in the original f of x function. So we're going to replace all the x's here in the 2x squared plus 3x minus 5 with x plus h. That's going to give me 2 times x plus h squared plus 3 times x plus h minus 5. So this is equal to the limit as h approaches 0 of 2 times x plus h squared plus 3 times x plus h minus 5. That was f of x plus h. Minus parentheses, real important about parentheses around the f of x function. F of x function was 2x squared plus 3x minus 5 all over h. Okay? This is equal to the limit as h approaches 0 of 2 times, I'm going to FOIL out x plus h quantity squared. That's going to give me x squared plus 2xh plus h squared. X squared plus an xh plus another xh makes a 2xh plus an h squared. Here I'm going to distribute the 3's. That'll be plus 3x plus 3h minus 5. Here I'm going to distribute the negative. That's minus 2x squared minus 3x plus 5 all over h. So this is equal to the limit as h approaches 0 of. Here I'm going to distribute the 2. That gives me 2x squared plus 4xh plus 2h squared plus 3x plus 3h minus 5 minus 2x squared minus 3x plus 5 all over h. Now if I did this problem correctly, guess what's going to happen in that numerator when I'm doing these derivatives of these polynomials? Half this stuff will cancel. What cancels? Well, the 2x squareds cancel. The plus 3x, the minus 3x cancels. The minus 5, the plus 5 cancels. Half the stuff. The entire f of x function actually cancels out. This leaves you with the limit as h approaches 0, 4xh plus 2h squared plus 3h all over h. And when you're doing this definition of derivative with the limit as h approaches 0 of f of x plus h minus f of x all over h, the ultimate goal is to cancel that h out of the denominator. Once you full out and do the algebra here, what you got in common in all those terms in that numerator? H. And remember, you got to factor it out, because only through strict multiplication division do things cancel. So the limit as h approaches 0 of h times 4x plus 2h plus 3 divided by h. H is canceled. So this is equal to the limit as h approaches 0 of the resultant 4x plus 2h plus 3. And now what's the last thing you're going to do? Once you clean off the h's cancel. Plug in 0. When you plug it in, you don't write limit anymore. You plug in 0 for h, not x. So it'll be 4x plus 2 times h is 0 plus 3. That term goes away, leaving you with 4x plus 3. Therefore, f prime of x is equal to 4x plus 3. This is the work we want to see when we hear the words, you use the definition of derivative to find derivative of somebody. However, we focused on, in section 2.2, 3 different kinds of problems. We focused on polynomials, like this one. We focused on radical equations, the 2 times the square root of x plus 5 type problem. And we focused on rational expressions, basically fractions, lack of a better term. 2 divided by 3x, want to take derivative of that guy. And so you know, it took some doings for us to actually do the definition of derivative. But this is what we expect to see on your test number 1. What section 2.3 is about catching the pattern. Because it takes too long to take these derivatives. Because we're going to use this stuff. And if I have to spend all my time in calculating the derivative, we'll never get around to using the stuff. But luckily, the great masters of math, 400 years ago, discovered a pattern. And what we're going to learn today is about the quick pattern, the fast way of taking a derivative because of all the limit stuff and what's exactly going on. So you'll notice here, the original function was f of x is 2x squared plus 3x minus 5. The derivative is 4x plus 3. Where are they getting that 4x plus 3 from? Well, with the x squared, if they multiply the exponent 2 times the coefficient out front 2, that gives you the 4, and then you got to subtract 1 off that x, that'll be 4x. The derivative of 3x, 3 times a variable, is just the variable, and the derivative of constant ends up being 0, and you can see quickly that, hey, if this pattern works all the time, I can do derivatives quickly. And that is what section 2.3 is about. The short way, the fast way of taking derivatives. So, pure memorization. But so much easier than actually trying to do this definition limit. Rule number 1, when it comes to derivatives, if f of x is a constant, the derivative is going to be equal to 0. Why? Well, first off, let's look at it from a geometry perspective. You guys have been programmed. When I tell you what is the geometric representation of the derivative, what are you going to tell me? Slope of the tangent line. Excellent. You've been programmed. Slope of the tangent line. What is it? If y equals 3, what does that line look like? Y equals 3. It's a horizontal line. What is the slope of a horizontal line? 0. So it doesn't, and all the lines are horizontal, so no matter which point you take, they're all going to be kind of connected on the tangent line there. So the derivative of a constant is 0 because the slope of a horizontal line is 0. If f of x equals x, what's the derivative? It's 1. The reason why, well, it's the slope. Well, the slope of y equals mx plus b is the m part. You with me? mx, you get the coefficient in front. The coefficient in front of the x is 1. So if I give you this, f of x equals a constant times x, guess what the derivative is? Just a constant out front, because that is what the slope is based on the old y equals mx plus b stuff. Okay? But then there were patterns. And that pattern I showed you a few seconds ago about derivative of x squared, you pull the exponent out front, we wrote it as a rule. It's called the power rule. And you know you're in trouble when they start labeling these guys with names. If f of x equals x to the n, the derivative is going to be nx to the n minus 1. So, if I have something like this, y equals x cubed, you know what the derivative is going to be? You bring down the exponent, 3, x, and then you subtract 1 from the exponent. 3 minus 1 is 2. So the derivative of x cubed is 3x squared. And it doesn't matter if you got a constant in front of it or not. Constants hold over. So the derivative of a constant times x to the n, you hold the constant, you still bring down the exponent and multiply to the raised to the x to the n minus 1. So if I had this, y equals 5x squared, do you know what the derivative is? Y prime is going to be 5 times, derivative of x squared is going to be 2x to the first, and you clean it up, 5 times 2 is 10, x to the first is just x. So it's the same thing as 10x. Derivative of 5x squared is 10x. And man, this sure beats taking that limit as h approaches 0 and beating that algebra to death. Okay? So, some fast rules here. If f of x equals a constant times g of x, then f prime of x is a constant times g prime of x. In English, constants hold over. You got a constant times a variable. You're taking derivative of the variable. Constant, just leave him out front, and he'll hold over, and you take derivative of the x part of the function, and then you just multiply it back again. Constants hold over. It's called the sum difference rule in these last two. If you got a function That's two functions being added or subtracted. And I want to take its derivative. I take derivative of each one and I add or subtract them accordingly. So, an example of that would be something like, what is the derivative of, let's see here, let me get a good problem here. How about this one? 2x squared plus 3x minus 5. What's the derivative? Well, 2 is a constant, leave it alone. What's the derivative of x squared again? You bring down the exponent to x and you subtract 1. That'll be 2x to the first power. Sum difference rule would be plus, what's the derivative of a constant times x? Just a constant, 3. Minus, derivative of a constant by himself is 0. So when I clean this up, I get 2 times 2x, which is 4x plus 3, and that's my derivative using the fast rules. And the reason why I chose that example is because that's actually the exact same problem we just did. F of x is 2x squared plus 3x minus 5. The derivative is 4x plus 3. And you don't have to sit there and kill half a sheet of paper and a whole forest of trees with a whole big class here and taking derivatives. Does that make sense? Now, for a function that is being multiplied, okay, or divided, it does not work that you just do the product of, just take derivative of each part of the product or each part of the quotient, and that'll be your derivative. It doesn't work like that. There's going to be called special rules, called a product rule and a quotient rule, and these aren't it. Okay, you can only do this sum difference, take derivative of the first one plus the second one, only works with if you're adding or subtracting these guys. When you're multiplying them, don't worry, we got section 2.4 to worry about multiplication and division. But since we are giving you guys the derivative formulas, these are your basic function derivative formulas here. We decided to go ahead and might as well launch it at you on all the other ones you got to have memorized. And the other ones you got to have memorized, which we haven't proved to you yet, which I will eventually, but you got to have it memorized. We decided to just go ahead and type up the whole page of stuff you guys have to memorize. Here are your trig formula derivatives. The derivative of sine of x is cosine of x. The derivative of cosine of x is negative sine of x. You know, you think about it. A sine is a wave. Starts at the origin, then goes up and comes back down. If you analyze every point along the cosine graph and look at its derivative, and connect the dots of all the derivatives, you end up getting the derivative of sine of x is the cosine. The cosine graph comes out of it. And the derivative of cosine of x gives you negative sine of x. The derivative of tangent is equal to secant squared, which is the same thing as 1 over cosine squared, if you think about it. But the derivative of tangent, secant squared. Derivative of cosecant of x is negative cosecant of x, cotangent of x. Derivative of secant of x is secant of x, tangent of x. And derivative of cotangent of x is negative cosecant squared of x. And people look at this and go, I will never get this thing down in my head. This is too difficult. Nah, it's math. It's designed to be easy. Key to math, catch a pattern. What's the pattern? The first pattern you need to pay attention to is this. The derivative of a cofunction is always negative. Derivative of cosine is negative sine. Derivative of cotangent is negative cosecant squared of x. The derivative of cosecant of x is negative cosecant of x, cotangent of x. Okay? The derivative of the cos are always negative. The other one is catch a pattern. Derivative of sine is cosine, and being a cofunction, derivative of cosine is going to be sine, but being a cofunction is negative sine. Derivative of tangent, secant squared. You got to have that one memorized. Derivative of tangent, secant squared. But the derivative of cotangent, being a cofunction, is going to be negative. It's cosecant squared. Catch a pattern. Cos matches to cos. Derivative of secant of x is secant of x, tangent of x. So therefore, the derivative of cosecant of x, catch the pattern. Okay, it's a cofunction, so it's negative cosecant of x, cotangent of x. There's a definite pattern with these guys. That's how you get them memorized so quickly. Does that make sense? Okay, don't worry. I'm going to go back and I'm going to prove most of these things for you guys. But we're just introducing formulas that you guys need to know and have memorized. So, hopefully you watched the awesome pre-section video on this particular material. where I actually went through and tried to discuss with you guys all the things that were going on. And I did a bunch of problems on the pre-section video. But remember this, if you learn anything about calculus and these derivative rules, it is this. Clean it up first. You know, what I call John's fundamental theorem of calculus here. It's just better to do your algebra before your calculus than afterwards. Clean it up. That's going to be the key to this stuff. That's why algebra is a prerequisite to getting into any calculus class. You got to have great algebra skills. So, and I did a bunch of problems for you guys over here, and so through 11. So I'm going to pick it up with problem number 12. Okay? Because I did all these for you guys before with the word video written on. All right, so please go back. If you didn't take notes off the video, go back, watch the video again, and take notes off of it. All right, take a look at this first guy. P of x is equal to x cubed plus 4x squared divided by x. Now, as I mentioned before, right now, not at least till the next section, we do not have a rule for taking derivative of quotients or products. So if we got a long division, I don't know how to do that. Okay? Or something being multiplied, I don't know how to take derivative of that yet. That'll come in the next section. So in this section, when they do give you a product or a quotient or something like that, what you are honestly supposed to do is do the algebra first. They're trying to get you programmed to do the algebra first. So because you're dividing by a single term, x, you can clean this up by taking the numerator, x cubed, first term, and divide it by x, plus the second term of the numerator, 4x squared, and divide it by x. Basically, you're taking your common denominator and putting it back under each term in the numerator. So now clean it up. What is x cubed divided by x? X cubed divided by x is x squared, plus 4x squared divided by x. Well, one of the x's canceled, leave me with 4x. Now, take derivative. Also, something very important. Labeling is everything in calculus. You don't label, you don't get the points for it. You got to tell me who the guy is. Everybody's got names in this world. P of x is equal to x squared plus 4x once you clean it up. So therefore, P prime of x is what? What was that derivative of x squared again using the power rule? The power pops out front to x and you subtract 1. Let's do it first. Plus, what was the rule about derivative of a constant times x? Well, what's derivative of 4x? The constant, 4. And there's my answer. Look at the second one, or number 13 if you will. D of x is equal to x plus 3 squared. We don't have a rule for stuff inside the parentheses and stuff outside the parentheses. Don't worry, that's chapter section 2.5. We'll get you there too. What they want you to do is clean it up. If it's not a rule that was on the sheet just before this, clean it up. Now, how do you clean up x plus 3 squared? Well, what does it mean to be x plus 3 squared? That's x plus 3 times x plus 3. So what am I going to do? You got it. I'm going to FOIL this thing out. Slide it over, you guys can see this. I'm going to FOIL this thing out. And x plus 3 times x plus 3 is, well, x times x is x squared. X times 3 is 3x. 3 times x is another 3x. That makes it plus 6x plus 3 times 3 is 9. So I didn't do anything but algebra on folding this guy out. Now I can take its derivative because it's in the rule. Some difference, I can take derivative of each term. And labeling is everything, so d prime of x would be equal to, well, derivative of x squared again is 2x, plus derivative of 6x is 6, plus derivative of 9 is 0. Typically I don't write that. So d prime of x is equal to 2x plus 6. I got a question for you. You see this function, x plus 3 squared? What's the slope of the tangent line when x equals 5? What's the slope of the tangent line of this function, d of x equals x plus 3 squared, when x is equal to 5? What was that slope of the tangent line? 16. What am I going to do? I'm going to take that 5 and plug it into the derivative. 2 times 5 is 10 plus 6 is 16. So the slope of the tangent line when x equals 5 of that original d function is actually 16. Oh, I'm sorry. I meant negative 2. What's the slope of the tangent line of x plus 3 squared when x is negative 2? 2. It'll be d prime of negative 2. That'll be 2 times negative 2 plus 6. 2 times negative 2 is negative 4 plus 6 is 2. It's the beauty of the derivative. You change your mind on what points you want. All you got to do is plug in derivative, and you can get these slopes all day long. Let's see if you guys have it memorized yet. This is calculus class. We look at something for 30 seconds. We expect it to be in your brain for the rest of your life. So, here it is. F of x is equal to the sine of x plus the tangent of x. So we're practicing, and since this is pure memorization, we decided to go ahead and throw some trig questions at you, see if you guys have those rules memorized yet. Even though I haven't proved it to you yet, and I will prove to you derivative sine of x is cosine of x, so forth and so on. Derivative tangent of x is going to be secant squared of x. And I'm going to prove those to you, but right now, we just want to make sure you get these things memorized. So, what is derivative sine of x? Cosine of x plus, what was derivative of tangent of x again? Very good. Secant squared of x. All right, 15. G of x is equal to 2 cosine of x plus secant of x. Labeling it, what's g prime of x? Well, 2 is a constant, it holds over. What's derivative cosine of x, being a cofunction and all? Negative sine of x, and the negative times that 2 makes it negative 2 sine of x. Plus, what was derivative secant of x again? Very good. Secant of x times tangent of x. Take a look at number 16. F of x is equal to the cube root of x minus the cotangent of x. First things first. Look at all the rules we have. We don't have anything with radicals in it. You want to clean up radicals. Remember, square root's a half a power. What do you think that cube root's going to be? 1/3 power. So algebra first. So f of x is equal to x to the 1/3 minus the cotangent of x. Now, labeling is everything. So f prime of x is equal to, here we go. What is the policy in terms of what's derivative of x to the n? I don't care what n is. You bring down the exponent, x, and then you subtract 1. So, what's derivative of x to the 1/3? You bring down the 1/3, x, and subtract 1. What's a third minus 1? Negative 2/3. Minus, what is the derivative of the cotangent of x? Very good. Negative cosecant squared of x. And of course, I would clean this up because it would bother me to leave it like that. This is 1/3 x to the negative 2/3. So negative and negative makes it plus cosecant squared of x. There's my derivative. But notice how I was very instrumental in changing the algebra to make it turn into one of my formulas. More examples. Well, also remember, if you can do the first derivative, you can do the second derivative, third derivative, and 45th derivative if you need to. If f of x is equal to x cubed plus 4x squared minus 2x plus 4, find f prime of x. On your mark, get set, and go. What's the derivative of x cubed? 3x, subtract 1 squared, plus, what's the derivative of 4x squared? Well, 4 is a constant, it holds over. Derivative of x squared is 2x. But you can go ahead and multiply this stuff in your head. What's 2 times 4? That'll be 8x minus, what's the derivative of 2x? 2. And derivative of 4 by himself is 0. So there's my derivative. F prime of x is equal to 3x squared plus 8x minus 2. What's f prime of 2? What am I going to do? I'm going to plug in 2 in for all my x's in my derivative. What's 2 squared? 4 times 3, 12. Plus, what's 8 times 2? 16 minus 2. Well, 12 minus 2 is 10, plus 16 is 26. Did you actually need a calculator to do all that? Hope not, because second test, we don't get to use calculators. All right? What's f double prime of x? What's my second derivative? Right, it's derivative of the derivative. Derivative of 3x squared is 6x plus, what's the root of 8x? 8, and the root of the minus 2 is 0. So f double prime of 2 would be 6 times 2 plus 8. That's what? 12 plus 8, which is equal to 20. Does that make sense? Well, can they make them nasty? Sure. Look at the next problem. G of t is equal to 4t squared plus t plus 5 divided by the square root of t. Once again, I don't do square roots. What's the square root? 1/2 power. And once again, I don't have a rule for doing a function over a function. Not yet, anyway. So what I'm going to do is I'm going to clean this up. So I'm going to take that square root of t, which is t to the half, and put it under each term in the numerator and clean them up. So this is 4t squared divided by t to the 1/2 plus t divided by t to the 1/2 plus 5 divided by t to the 1/2. And I'm going to keep cleaning them up here. So when you divide, you subtract exponents. So t squared divided by t to the half, 2 minus a half is 3/2, so that's 4t to the 3/2. Plus t, which is the same thing as t to the first, divided by t to the 1/2. When you divide, you subtract exponents. But 1 minus a half is a half. And I don't like stuff on the bottom. When I got stuff on the bottom, I'm going to bring it to the top, but what happens? The exponent becomes negative. So all this is to make it look like something I can take a derivative of based on my rules, cleaning up my algebra. So what is g prime of t? Well, I'm going to make sure I don't screw this up. So this will be 4 is a constant, holds over. Derivative of t to the 3/2 is you bring down the power, 3/2 t to the negative, when you subtract 1, 3/2 minus 1 is positive 1/2, excuse me. Okay, plus derivative of t to the 1/2 would be 1/2 comes out front, t subtract 1 would be negative 1/2. Plus 5 is a constant, derivative of t to the negative 1/2, the negative 1/2 comes up, t, but then you've got to subtract 1 from a negative 1/2, which gives you negative 3/2. So of course you want to clean this up. Let's see here, 2 goes into 4 2 times, and 2 times 3 is 6. That'll be 6t to the 1/2 plus 1/2 t to the negative 1/2. 5 times negative 1/2, it gives me negative 5/2 t to the negative 3. That is my first derivative. What is the derivative g prime evaluated at 1? What am I going to do? I'm going to plug 1 in for t. This will give me 6 times 1 to the 1/2 power plus 1/2 times 1 to the negative 1/2 power minus 5/2 times 1 to the negative 3/2 power. 1 to any power is what? I don't care if it's a negative exponent or positive exponent. 1. So this pretty much gives you 6 plus 1/2 minus 5/2. Do I need a calculator for that? Well, let's see. Positive 1/2 minus 5/2. Well, we've got the common denominator. 1 minus 5 is negative 4. Negative 4/2, which is minus 2. And 6 minus 2 is 4. The answer is 4. My point is, I don't need a calculator for everything in this world. But of course, what's the next thing you got to do? Second derivative. That's why I was very neat on trying to do the first derivative. So what's their second derivative going to be? Well, given with fractions, t to a power, you bring down the power. 1/2 times 6 is what? 3t, and subtract 1 gives you negative 1/2. 1/2 t to the negative 1/2. Derive that, and take down the negative 1/2 times the positive 1/2. That'll give you negative 1/4. T to the subtract 1, that'll be negative 3/2. Watch this one. Negative 5/2 t to the negative 3/2. Derive that would be the negative 3/2 times the negative 5/2 gives you a plus 15/4. T to the subtract 1. Subtracting 1 from negative 3/2 is negative 5/2. And they want me to plug in 1. So this will be 3 times 1 to the negative 1/2 power, minus 1/4 times 1 to the negative 3/2 power, plus 15/4 times 1 to the negative 5/2 power. Well, 1 to any power is 1, so it'll be 3 minus 1/4 plus 15/4. Can you do this without a calculator? Well, let's see. What is minus 1/4 plus 15/4? That would be 3 plus 14/4. What's 14/4? Same thing as 7/2. And if you go for the common denominator, this will be 6 over 2, which is 3, plus 7 over 2. And 6 plus 7 is 13/2. Or for my engineering majors out there, what's 13/2? 6 point what?
5?
Thank you. Yeah, good. I feel better about life. Okay, good. 6.5. Good. All right. Oh, on page 6. 6.5. Does that make sense? Questions? All right, getting used to the old notation here. H of x is equal to x to the 5th minus 2x to the 4th plus 3x cubed minus x minus 6. Your mission? Find the first 6 derivatives. Well, I want to teach you a little bit about calculus here. You know, every time we do a derivative, it's a little prime hash mark, up to a point. Gets a little old if you're going to make me take 6 derivatives. So I'm going to show you what the proper notation for these derivatives is. All right, we're using the Newtonian notation. So the first derivative will be h prime of x, which would be what? What's the derivative of x to the 5th minus 2x to the 4th plus 3x cubed minus x minus 6? Well, the derivative of x to the 5th is 5x to the, subtract 1, 4, minus, what's the derivative of 2x to the 4th? Well, 2 times 4 is 8x, what? Cubed, plus, derivative of 3x cubed, 3 times 3 is 9x, subtract 1 squared, minus derivative of x by himself is 1, derivative of minus 6 is 0. So there's my first derivative. Notation, h with a hash mark on it. Second derivative, h with 2 hash marks on it. Second derivative, derivative of 5x to the 4th, 5 times 4 is 20x cubed. Derivative of minus 8x cubed, 3 times a minus 8 is a minus what? 24x squared. Plus derivative of 9x squared, 2 times 9 is what? 18x to the first. My derivative of minus 1 is 0. Does that make sense? Third derivative, notation, 3 hash marks. Derivative of 20x cubed is 3 times 20 is 60x squared minus derivative of 24x squared is 48x plus derivative of 18x is the coefficient 18. The fourth derivative, that's where things starting to change over. It is perfectly acceptable to write 4 hash marks if you want to. But after a while with these derivatives, we're going to go Roman numerals on it. That's typically the notation, so you don't have to write so many hash marks. So this would be the fourth derivative of x, h with a little IV 4 up there of x. Well, the derivative of 60x squared is 120x, minus derivative of 48x is 48, and derivative of 18 is 0. The fifth derivative, h with a v on him, would be equal to, what's the derivative of 120x minus 48? 120. Derivative of 120x is 120. Derivative of minus 48 being constant 0. What is the sixth derivative? H v. I get, of x there, I get 0. So what is this derivative? H m c m x l I of x. It's 0. You're right. I just want to know if you guys know your Roman numeral. Which derivative is this? All right. What does m stand for in Roman numeral? We better start from the beginning. The 1, you know 5, right? What's 10? X. What's L? 50. What's C? 100. What's D? Very good. 500. And M? 1,000. But the Romans, when you put one of the smaller letters, smaller numbers in front of a big letter, you got to subtract. So what's MCM? MM is how much? 2,000, right? But you got a C in front of one of the M's. So you got to subtract off, and the C is 100. So if I subtract off 100 from 1,000, what am I left with? 900. So this is 1,900. What is XLII? Well, L is 50, but with the X in front of it makes it 40. II? 2. Yeah, it was 1942 was a year, actually. That's what the derivative you're taking. Does that make sense? Yes. Is it going to be on your next test? No. But it's important in life? Yes. Anytime you want to figure out what year an old movie was made, that's always doing Roman numerals. All right, there you go. All right. Here we go. Normal and tangent lines to a function. Now, you know we've already beaten to death this tangent line. The equation of a tangent line and all this other good stuff. Yeah, but what exactly is a normal line? A normal line is a line that is perpendicular to the tangent line. Perpendicular. And what do we know about perpendicular slopes? I don't know, math 1, math 2, I don't know when you guys did perpendicular slopes. What's the deal on perpendicular slopes and what's the formula? Negative reciprocals, right? So if I wanted to know what the slope of the normal line is, it's the negative reciprocal, it's perpendicular, negative reciprocal to the tangent, which means it's going to be -1 over the slope of the tangent line. So an example. What is the negative reciprocal of 2/3? -3/2. You flip the fraction and change the sign. What's the negative reciprocal of -5? 1/5. You flip the fraction and change the sign. Negative, negative's back to positive again. What's the negative reciprocal of pi? Make it a fraction, pi over 1, flip it, 1 over pi, and make it negative. -1 over pi. You got it. All right. So, here it is. Find the horizontal tangent lines, and that's kind of a clue. Remember, we did horizontal tangent lines. Those are slope of 0 to the function f of x equals 2x cubed plus 3x squared minus 120x plus 23. They want you to find basically all the horizontal tangent lines. To find a horizontal tangent line, that means the tangent lines have to have a slope or a derivative equal to 0. So how to find these guys is this. You've got f of x is equal to 2x cubed plus 3x squared minus 120x plus 23. I'm going to take the derivative of this guy. The derivative is going to give me a function that represents the slopes of the tangent lines. The derivative of 2x cubed is 6x squared plus derivative of 3x squared is 6x minus the derivative of 120x is 120 and the derivative of 23 is 0. So my derivative is 6x squared plus 6x minus 120. You with me? To find where we have horizontal tangent lines, we're going to take derivative, and horizontal lines have slope of what? 0. We're going to take the derivative and set it equal to 0. Now I'm going to solve for x. Well, it becomes a quadratic here. 6x squared plus 6x minus 120 equal to 0. What do you got in common each one of these terms? You can factor out a 6, leave you with x squared plus x minus. When I take a 6 out of 120, what am I left with? No, try again. 6 out of 120. How about 20? Yeah, that's even better. 20. 20 times 6 is 120. Equal to 0. And this was not a web-work problem, so it should factor. All right, so here it is. X squared plus x minus 20. What times what is 20? That differs by 1. 4 and 5. And because it's minus, they're opposite signs. Which one's going to get the plus? plus, because the bigger number is going to have to get the plus, and the small number is going to get the minus because the plus of the x there. Set each factor equal to 0 and solve. X equals 4 and x equals -5. However, they ask you to find the horizontal tangent line. Just a little note here. A horizontal line looks like what? Y equals B. Horizontal lines are y equal equations. You with me? When I took the derivative, set it equal to 0 and solved, I solved for x. That's not what I need. I need y. How am I going to get y back again? What am I going to have to do to get y back again if I need a y coordinate? You plug it into the original equation. If I plug it in derivative, I hope to get 0. To get y, remember y and the f of x are the same thing. So, to get y would be equal to f of 4, and the other y would be equal to f of -5. So y would be equal to 2 times 4 cubed plus 3 times 4 squared minus 120 times 4 plus 23. Do you need a calculator for this kind of a problem? Yeah, me too. So let's go ahead. I won't give you this one on the test then on the next one. So let's use the calculator here. 2 times 4 cubed plus 3 times 4 squared minus 120 times 4 plus 23. And I get y equals -281. -281. There is one horizontal horizontal line, horizontal tangent line. Y equals -5. This will be y equals 2 times -5 cubed plus 3 times -5 squared minus 120 times -5 plus 23. And so I'm going to go is call this thing back down again and change all those 4's to a -5. So insert -5 and delete the 4. Insert the -5 and delete the 4. Insert the -5 and delete the 4. Plus 23. So there it is. And when I plug it in, I end up getting y equals 448. And I know this is why I'm doing this problem, because it is a WebWork style problem here. It's frustrating where you see students get this kind of a problem and they basically do everything right. They took derivative, they set it equal to 0 and solve. And then they plug in x is 4 and they plug in -5. And why WebWork is counting it wrong is frustrating them to no end because they didn't finish reading the question. The question is not where's the x coordinate to the horizontal tangent lines, then you got it. Because x is -4, x is +4, x is -5. The question is find the horizontal tangent lines. The horizontal line is a y equals number, so you had to go take your x and plug it back into the original equation to get the y part of it. Does that make sense? It's little things like that make calculus tough. Got to read directions. Let's see if you guys know some trig. Try this one. Find the tangent and normal lines to the function of f of x is equal to 4 cosine of x at x equals pi/3. All right, so now we're going to start quizzing you guys on your trigonometric skills and stuff like that. All right, first things first. There's the two parts of this thing. Part A is find the tangent line. Part B is going to be find the normal line. Okay? So here we go. Anytime you hear the words, find the equation of the, I don't care, whatever, line. Tangent line, normal line. When you hear the words, find the equation of line, I'm trying to program you because the amazing thing is people look at me and go, I don't know where to start. You know exactly where to start. when you hear the words, find the equation of a line, tangent line, normal line, whatever. Find the equation of a line, what you going to start with? Point slope. What's your point slope formula? Y minus y1 equals m times x minus x1. Anytime you hear the words, find the equation of a line, use the point slope formula. Which means you got to have two things. What you got to have? We're math people, don't think too deep in this. Point and a slope, right? Let's get a point. Well, they gave me a function. You had to do that. F of x is 4 cosine of x. And they gave me x equals pi thirds. They gave me half a point. They gave me the x coordinate. The x coordinate is pi thirds. How do I get the y coordinate? What am I going to do? I'm going to plug it into the original equation. This will be 4 times the cosine of pi thirds. Does that make sense? Now, my question to you is this. What is the cosine of pi thirds? Now, pi thirds, you may know that better as 60 degrees, but we need to be radians in this class. So, cosine is the x-coordinate. What is it? That is exactly what it is. Things we know from high school. 1/2 times 4. So, y equals a half of 4, which is what? 2. So, the point is pi thirds, comma 2. There's my point. And I'm looking at you people going, and I can see your expression on face. Oh my God. I don't remember all that stuff about cosine of pi thirds. Well, did you graduate high school? Yes, you had to get in college. All right. And I want to remind you of something or other. I gave you guys some stuff, whether you use it or not, I don't know. But if you go back to modules up here, and go way up here where it says other resources and stuff, on campus, learning opportunities, note, supply list. I got some information here. Where did I put it? Oh, preview, prerequisite review. I got to remember where I put it. There it is right there. I put it under the prerequisite review. Right here. What does it say? Unit circle, trig identities, and common angle. Here's all the stuff you're supposed to have memorized from high school. And you can print this thing out if you want to. Do you guys remember the old unit circle you're supposed to from geometry class? You basically just had to have that first quadrant memorized, and then it patterned itself throughout the different quadrants. But remember, on the unit circle, x is the cosine of the angle, the y coordinate is the sine of the angle. So you just had to figure out where the angle is at. So here's your first quadrant. We were talking about pi thirds, and you got this attached point, 1/2 square root of 3 over 2. What was the x coordinate? 1/2. The cosine of pi thirds is 1/2. Does that make sense? Just reminding you on how to use this thing. And you can, like I said, you can print this thing out. But it's calculus. You're expected to have it memorized. All right. So this should not be anything foreign to you, cosine of pi thirds, but you may have to go back and review some trig just to make sure you know this stuff. But then times 4 makes it 2. There's my point. Now I got to have the slope of the tangent line. But to get the slope of the tangent line, what do I got to have? Derivative. Well, 4 is a constant. Let's see what you guys have memorized yet. What's derivative of cosine? Being a cofunction, it's negative sine. So it's 4 times negative sine of x, or better yet, negative 4 sine of x. But to get the slope of the tangent line, you got to actually take your derivative and plug in the x coordinate that you wanted. Our x coordinate was given to be pi thirds. So this will be negative 4 times the sine of pi thirds. And hopefully you paid attention to what I was just talking about on that unit circle a few seconds ago. If the cosine of pi thirds was 1/2, what do you think the sine of pi thirds is going to be? Very good. Square root of 3 over 2. You're going to clean it up. So 2 goes into 4 2 times. So that's actually 2, negative 2 times the square root of 3. So my slope of my tangent line, I didn't say this is going to be a pretty problem, is going to be negative 2 square roots of 3. So now I'm going to take my point and my slope and plug it into the point slope formula. So I get y minus the y coordinate, which is 2, equals the slope of the tangent line, which is negative 2 square roots of 3, times x minus the x coordinate, which is pi thirds. And literally, you plug into this formula. Now, We've got the answer, but it's not pretty. So, typically what we do, especially with web work, you know I stole this problem, is we're going to solve for y and go put it in that fashion. So if I solve this thing for y, it's not going to be pretty either. It'll be y minus 2 equals negative 2 square roots of 3 times x. And negative times negative would be positive 2 square roots of 3 times pi divided by 3. I just multiplied those two irrational numbers together and get that. I'm going to add 2 to both sides, solving for y, and I got y equals negative 2 square roots of 3 times x plus 2 square roots of 3 pi over 3 plus 2. There is the equation of the tangent line. Does that make sense? Sorry, you got a lot of pi's and square roots of stuff in here. It's not going to clean up nicely. But now, part B asks you this. What is the equation of the normal line? Find the equation of the, don't care what the word is, line. What am I going to use? Point slope again. So point slope formula is y minus y1 equals m times x minus x1. Slope of the normal line, so we'll put a little subscript in on that thing there. We've got to have two things, a point and a slope. Well, the function was the same, the x-coordinate's the same, so the y-coordinate's the same. So I've got the point waiting for you here. It's the same point, and that point happens to be, what was it, pi thirds comma 2. It's the same point as what we had up here. Now here's the deal. You remember in the last problem, the slope of the tangent line was negative 2 square roots of 3. So what does that make the slope of the normal line? Being they are perpendicular. Negative reciprocal. So it's going to be negative 1 over the slope of the tangent line. It's negative 1 over negative 2 square roots of 3, which makes it positive 1 over 2 times square root of 3. There's my slope of my normal line. And then I go back and plug them in the same way. Y minus the y-coordinate, which is 2, equals the slope of the normal line, which is now 1 over 2 square roots of 3, times x minus the x-coordinate is pi thirds. So basically, if I look at these two equations plugged into the point slope formula, the only thing that's going to change is going to be the slope. And it's the negative reciprocal of the tangent line to get the normal line. But again, it's web work, so I'm going to have to clean this thing up. So I'm going to distribute y minus 2 equals 1 over 2 square roots of 3 times x minus pi over 3 times 2 is 6 times the square root of 3. Just did combine those two things together. And then I'm going to add 2 to both sides. And I get y equals 1 over 2 square roots of 3 times x minus pi over 6 square root of 3 plus 2. Does that make sense? So, and you start asking yourself, you know, the big deal about tangent lines and normal lines and all this other good stuff. So over here, if I happen to have an interesting curve, something like this, here's old f of x right here, and I'm interested in this point right there, what would the tangent line be? Comes in, hits that point, and then moves off and just touches at that point. So there is my, I'll just do tan for tangent line there. What would the normal line be? It's going to be perpendicular to this guy, and it would actually go straight into the curve. Perpendicular. This is the normal line. Does that make sense? To your curve. And so when you are actually looking at things like going around a track, for you motorsports engineers out there, you're going around a track and you've got a nice full circle, you know, you sit there and talk about which direction is your velocity, which direction is your acceleration, and what's actually holding you into that turn is going to be basically the path on that normal line, because it's this. They think about your forces that are going around the circle and stuff like that, and keeping it in that line. To the velocity will be that a normal line there. Speaking of that kind of stuff, we have here applications of physics stuff here and how it relates back to the derivative. Position, velocity, and acceleration. If the motion position of a particle is known, we can find the velocity acceleration functions in the following way. We typically talk about position or distance, if you will, of a particle is given by f of x. Then the velocity of a particle is given by f prime of x. In English, the derivative of position is velocity. Okay? If the velocity particle is given by g of x, then the acceleration of the particle is given by g prime of x. In English, the derivative of velocity is acceleration. Put it all together, you got a position function. When I take its first derivative, that's going to give me velocity. When I take its second derivative, the derivative of the derivative, that's going to give me acceleration. Here is now the physics game that you'll be playing with this stuff. Position is your original function. The first derivative is velocity. The second derivative of position is acceleration. Okay? So, and then we typically talk about this thing in terms of time. So here is our standard notation. S, I don't know why, we just always called it S. S of t is your position, t stands for time. Okay? S is going to be position. And then after that, things get logical. When I take the derivative of S, that'll be S prime of t, that's called velocity. We'll call him V of t, V for velocity. When I take the second derivative of position, which is the first derivative of velocity, that's going to give me acceleration, A of t, where t is time, acceleration. Okay? So, here we go. A particle's position is described by the function s of t equals 3t cubed minus 144t. Okay? T is measured in seconds and s of t is in feet. Because it's physics, pay attention to units. Find the velocity function, find the acceleration function, find the acceleration after 9 seconds, and find the acceleration when the velocity is 0. All right, here we go. Find the velocity function. What's velocity? Velocity is the derivative of position, which is what? What's the derivative of 3t cubed minus 144t? Derivative of 3t cubed is what? 9t squared minus, what's the derivative of 144t? 144. What's acceleration? A of t. Acceleration is the second derivative of position, or the derivative of velocity. What is your second derivative going to be? 18t. Does that make sense? Now, pay attention to this problem. Find the acceleration after 9 seconds. What am I going to do? Plug 9 into t for the acceleration. So that'll be A of 9. So that'll be 18 times 9. And 18 times 9 is 162. But it's physics. If you don't give me units, I don't pass you. So, what would the units have to be on a word problem like this? What? Now, let's talk about units. Now, distance is measured in feet. Time is measured in seconds. When you take a derivative in terms of units, you always get a per. This is real important stuff. So, your velocity is feet, is the first derivative, so it's feet per second. Does that make sense? But your acceleration is the second derivative. So it's the derivative of velocity, so it's the second derivative, so it's feet per second, and then you took another derivative per second. It's feet per second, or feet per second squared. That's the per second thing here. Every time you take a derivative with this stuff, it's a per second, or per whatever time unit it happens to be. Okay? So velocity is feet per second, acceleration is going to be feet per second squared in this problem. This last one. Find the acceleration when the velocity is 0, or when the particle stopped. All right? Okay. This one is this. find acceleration, but the acceleration is based upon time. So, for me to figure out when the velocity is 0, I got to figure out the time it was 0. So what I'm going to do here is I'm going to take my velocity equation, which is 9t squared minus 144, and I'm going to set it equal to 0. I'm going to add 144 to both sides. I get 9t squared equals 144. I'm going to divide by 9 on both sides, and that's going to give me t squared is equal to 144 divided by 9 is 16. Does that make sense? Now what do I got to do to solve for t? Square root. So time is equal to what? No. No.
Seconds.
No, yeah, seconds, I'll give you that one, but not necessarily 4. Because you introduced a square root into a problem. What do you got options of when you do a square root? Plus or minus. I know you're thinking time, that it's got to be positive, but they said nothing about time having to be positive. Sometimes they have to actually let you know t has got to be greater than or equal to 0 to be positive. It's actually plus or minus 4 seconds. That's when the particle stopped, at the negative 4 second mark and the positive 4 second mark. So to get the acceleration after 4 seconds would be 18 times 4. And 18 times 4 is 72 feet per second squared. But, or and if you will, a of negative 4, because they did not restrict time on this thing whatsoever. So that'll be 18 times negative 4, or negative 72 feet per second squared. So there are 2 accelerations because there were 2 times that the particle stopped, because they never restricted the time about positive or negative. We will do some more of these guys next time, as well as, physics is real important next time, as well as going into section 2.4. And so even if we don't have time to wait, but it's not going to be on your test. Homework says due by Friday. See you guys on Thursday.
Can